Welcome back to another video, and in this video we are talking about the product rule, the quotient rule, and the chain rule. So now these are different rules that are a little bit more complicated when dealing with the derivatives, because some derivatives you can't actually figure out just by using the sum and difference rule here. So as we get along with it, we will do a lot of practice, and hopefully by the time we're done with the video, you should know a lot about it. So our first rule is the product rule. Now, the product rule states that if f and g of x are both functions, then the derivative of f of x times g of x is just equal to f prime of x times g of x plus f of x times g prime of x. Right? So now it's going to be like the first part of the equation is like the opposite of the second kind of the equation. So you have the derivative and then non-derivative. And then you add the non-derivative and then the derivative. So another way that we can memorize this is by what some people use, fig gif. Fig plus gif, right? In this, it's saying that f prime times the g and then the g prime times the f, right? So it's the same concept here. Now let's do an example together. So an example could be find the derivative of x plus 3 times x squared. Now you might say, hey, why don't we just, solve this out and then we can use a power rule, right? But the whole point of the product rule is that once you get into like trig functions, it's going to be a lot harder to figure out, and it's another simpler way of doing it so that you don't have to take that much time. So now we know that f of x, let's do this. We know that f of x is equal to x plus 3 because that's the first function. And then f prime of x is just equal to 1 since x is its own, x is a variable and the derivative of any variable is just 1. And then we have g of x is equal to x squared, while g prime of x is just equal to 2x. Now let's put that all together in this form. F prime x, g of x plus f of x times g prime of x, right? So f prime of x is just equal to 1, so we can cross that out, equals to 1. G of x equals to x squared, so we do x squared plus f of x, which is x plus 3, and then g of x, well, g prime of x is just 2x. In rare cases do they tell you to expand it, but in this case we will expand it because it's a lot easier. So that'll be x squared plus, let's see, 2x squared plus 6x. And that'll lead us to 3x squared plus 6x. And that is our answer here. Now, we can of course check this by just, factoring things out here. So the derivative of x plus 3 times x squared is just the same thing as the derivative of x cubed plus 3x squared. And by using the power rule here, the derivative of x cubed is just 3x squared, right? And then plus the derivative of 3x squared, which is just 6x. And we still get the same answer, right? Alright, so now try this example on your own, where you're asked to find the derivative of, let's see, what can I give you? The derivative of x squared times sine of x. Take a moment and pause the video here and try solving this out. Alright, hopefully you just took a moment and solved it out. We can tell that f of x, our first function, is just equal to x squared, and g of x is equal to sine x, right? Now, f prime of x is equal to 2x, and then g prime of x is equal to cosine x. Now, if we apply the rule that we had, was f prime x times g of x plus g prime x times f of x. Now, remember, using the commutative property, you can switch around the terms here. So now, just for uniformity, I'm just going to write it the other way around. F of x times g prime of x. And now we can start plugging in the stuff. So f prime of x in this case is just 2x times the g of x, which was sine x, right? Plus f prime of x, f of x is x squared times g prime of x, which is cosine x, right? Cosine x. And our simplified equation is just 2x sine of x plus x squared cosine x. Now that is our answer here. So it wasn't that bad, right? Now, a common mistake that people usually do when entering these problems is that they multiply the derivatives around. But in this case, do not multiply the derivatives around, because once you do that, then there serves no purpose of the product rule. And in this case, the x squared times sine of x, you can't really multiply that together before you evaluate the whole thing. So in some cases, you have to keep it like that. Now, continuing on to our next subtopic, it's the quotient rule. Now, the quotient rule is a lot similar to the product rule, just that instead of a plus, it's a minus, and then it's over the last function squared, right? So let's say that f of x and g of x are functions. Then the derivative of f of x over g of x is just equal to f prime of x times g of x minus f of x times g prime of x over g of x squared at the end. So now you might tell me, this is a little bit complicated, right? But you can tell that the beginning, the numerator, is a lot similar to the product rule, and then the only thing that changed was just the symbol, and also just that you put it over the original function, the original denominator squared, right? So using this rule, let's see if we can try to find this example. Let's do an example, right? So we're here trying to find the derivative of x cubed over x plus 1 here. Plus 1. Now, our upper function, our numerator, is just x cubed, right? And our g of x is just x plus 1. Now, f prime of x is just 3x squared, and g prime of x is just 1, right? So now, let's put it into the equation that we have here. So, of course, f prime of x times g of x minus f of x times g prime of x over g of x squared, right? So now, once we put it inside the equation here, f prime of x is 3x squared, right? 3x squared times the g of x, which is x plus 1, minus f of x is just x cubed, times the g of x is just 1, so we can keep it the same here. And that will be all over g of x, which is x plus 1, squared. Now, they usually don't tell you to simplify this, right? Because it sometimes becomes like a hassle trying to simplify it, right? So we're just gonna keep it like this. This is our answer. And yeah. So now let's try doing a practice problem by yourselves. So let's try it with this. So find the derivative of sine x over x. Try this on your own and pause the video here to figure it out. Alright, hopefully you just pause the video and try to figure this one out. So now, let's try to solve it. F of x, the numerator, is just sine of x. F prime of x, we all know it's just cosine x. G of x is just equal to x. And then g prime of x is just equal to 1, right? So now let's put this in the equation. So the equation is f prime of x times g of x minus g prime of x times f of x, right, over g of x squared. So now this would equal to f prime of x is just cosine x times the g of x is just x minus g prime of x is just 1, so f of x is sine of x, stays by itself, all over x squared. And that is our answer. So once you get into like a habit of these things, then it's going to be something that is going to click in your head very soon. A common mistake that people make is that they set it to addition instead of what's supposed to be like a subtraction. And also, you only square the denominator. You do not square anything else in this equation. Alright, so for our last rule for derivatives, it's called the chain rule. Now, the chain rule gets a little bit complicated because you're dealing with inside functions and outside functions. So you have to really break it down and see what you're trying to have here, right? So now, chain rule. We call it chain rule because at the end, it usually just forms a chain of like the terms and stuff. So that's why we call it that. And if f of x is the outer function, right? And g of x is the inner function. So now the derivative of f of g of x, that's what it's gonna look like. It's just equal to f prime g of x, the g of x stays the same, times the derivative of g of x, right? So that's what the whole entire point is. It's gonna get a little bit complicated for the first few times that you're trying to do the chain rule problems. For me, it was a little bit complicated for me as well. I didn't get it the first time, but as you practice more and more, then you're gonna understand it more. So now, since we have this, right, let's do an example here. Our example is find the derivative of 3x plus 2 to the 4th power. Alright, so in this case, we can tell that our outer function, which is f of x in this case, right? F of x is just equal to the parentheses to the 4th power, right? And now our g of x here is just equal to 3x plus 2, because that's the inside, right? There we go. That's the inside of the part. And then you have the g of x here. I mean, the f of x. We have exponent of 4, and over here you have exponent of 4 as well, right? So now we're going to try solving this here. So since we're using the base equation of f prime of g of x times g prime of x, right? That's just going to be equal to, we know that f prime, since it's to the 4th, right? We're going to make it seem like it's x to the 4th, just like as a placeholder, right? For the inner function. So since x to the 4, the derivative of x to the 4 is just 4x to the cubed, right? So 4 times the inner function here, 3x plus 2 to the cubed, times, now g of x is just 3x plus 2, but the derivative of g of x plus 2 is just 3. And that simplifies to 12 times 3x plus 2 to the 3rd power. Now you see how we took this spot here, the inner function spot, and just replaced it with g of x, right? So technically we can say that f prime of x is just equal to 4 to the something to the 3rd power, right? Because we're using that same power rule here, and then of course g of x is just equal to 3, right? Alright, so let's try an example on your own here and see how it works out. So the example that I will give you is of course with trig functions, and then we'll try another one. Find the derivative of sine of 5x. Pause the video here and try to solve this out. Alright, hopefully you just pause the video and try to solve this out. Our f of x, well, our f is just equal to sine of blank, right? And then our g of x in this case, the inner function, right, is just equal to 5x. 5x. Alright, so now, since we have to find the derivative of f prime of x, right? Now, the derivative of sine is just cosine, right? So just cosine in the parentheses. And of course, g prime of x is just equal to 5, right? The derivative of 5x, right? And the base equation says that f prime of g of x times g prime of x. So now that's just going to be equal to the cosine of 5x times g of x is just 5. And we can reorder these terms to make it look better by just moving 5 to the front here. So it will equal to 5 times cosine of 5x. There you go. That is the answer to this problem here. Now let's try one last example, but this one we're going to incorporate some exponential functions here. So find the derivative of e to the 2x squared. Take a moment and pause the video to try to find this out. Alright, hopefully you just solve this equation out, and let's try to solve it now. So our outer function is just e to the whatever power that we have here. Our inner function in this case is just the exponent, so 2x squared, right? Now, f prime of x is just equal to e of whatever exponent we have, because the derivative of e to the x is just e to the x, right? And of course, g prime of x is just equal to 4x, right? So now, let's try to solve this out here. Using the base equation of f prime of g of x times g prime of x. F prime is just e to the whatever power there is, so we can write that first. E to, well, g of x, right? G of x is 2x squared times the derivative of g of x. So that's going to be 4x. And once we reorder these terms, it's going to be equal to 4x times e to the 2x squared. There you go. See, it wasn't that hard. So now, make sure that you practice a little bit more, right? And of course, once you complete everything, right? Once you do everything, make sure that you double check it. And in the future, once you get to integrals, you're gonna have to really double check your work with all of these things. And once you get a good basis on derivatives, everything else is gonna be a lot easier than it should be. So make sure that you keep on practicing, and make sure you guys practice the product rule, quotient rule, and chain rule, because those are the three, one of, I would say, the most complicated rules out of everything. So make sure you practice those, and I will see you guys in the next video.